Hello and welcome to Biodiesel Magazine podcast. I'm your host, Katie Schroeder, Associate Editor with BBI International. Today, I am speaking with the sponsor of the 2024 Biodiesel Summit, Grace, and I am excited to connect and discuss the company's recently released white paper with Chelsea Grimes. Chelsea is a global strategic marketing manager at Grace. She is responsible for the vision and execution of strategic projects in the biofuels market and has spent the past 9 years in the specialty chemicals industry, working on removing various contaminants from oils while mitigating the environmental impacts of the refining process. Chelsea earned a Bachelor of Science in Chemical and Biomolecular Engineering from the University of Maryland, College Park. Welcome, Chelsea.
Thanks, Katie.
Yeah, thank you so much for joining us. So I hear that Grace is a company that has been around for over 150 years, and it seems like it has evolved a lot throughout that time. So could you tell us a little bit about who Grace is today?
Yeah, so a while back, Grace was known for owning cruise ships, restaurants, and even a national bank. We are proud of this rich history, but we've definitely continued to evolve and innovate over the time. So today, Grace is a global supplier of catalysts and specialty chemicals, privately owned by Standard Industries. We have operations in over 30 countries and customers in over 100 countries. Grace currently has four main business units, including specialty catalyst, refining technologies, materials technologies, and Grace's JV with Chevron, known as Advanced Refining Technologies or ART. As part of Grace's materials technologies business, we offer specialty silica products for a variety of applications, including coatings, pharmaceuticals, personal care, biofuel refining, and so on. Today, we have over 60 years experience supporting the biofuels industry, ranging from catalysts and adsorbents all the way to molecular sieves.
Wow, what a diverse and rich history. That's awesome. So it sounds like there are multiple different pathways to produce renewable diesel and SAF. How do you think these technologies will evolve over the next few years, and what challenges do you foresee?
Yeah, so today, the three most well known pathways to produce renewable diesel and SAF include alcohol to jet, the Fischer Tropsch pathway, as well as the hydroprocessing of esters and fatty acids, which the industry today calls HEFA. While the first two pathways are still in the demonstration phase and require significant production costs, the HEFA pathway is already commercially proven at scales needed to help decarbonize the transportation sector. All of these technologies and pathways, however, will be needed in order for the industry to achieve a true net zero. So today there's a lot of variation in terms of capital and operating expenses amongst all of these routes to production. For instance, the HEFA pathway can average between 1,000 and 1,500 US dollars per ton to produce, while on the other hand, the Fischer Tropsch pathway can be 5 times that amount. So the only way to really have an abundance of production pathways is, to make these costs more competitive to one another through increased investment in the sector. However, out until 2050, I really see the HEFA pathway as being the most cost-effective route to produce renewable diesel and SAF. Even though HEFA can really seem like a no-brainer, there's still quite a few challenges that this technology will face to get to the level of decarbonization the industry really needs. These include the supply security of waste feedstocks, the accelerated development of new cover crops, but the biggest hurdle is really overcoming the flexibility challenge as these feedstocks, the source and the quality can change day to day. Here is where, feedstock pretreatment really comes into play and has an enormous influence over these renewable refineries and how they'll operate day in and day out. The typical pretreatment process, it's really been around for decades as it was pretty much copied from the edible oil refining industry to remove contaminants that the hydroprocessing catalyst cannot tolerate. And these include things such as phosphorus and metals. In fact, the hydroprocessing technology providers that supply renewable diesel and SAF today, they actually set feedstock specifications on these elements before they come in contact with the catalyst. This is really a way for them to guarantee the plant's performance and catalyst life. So the pretreatment process itself, it's necessary, but it's pretty complicated as there's multiple variables that, you need to consider, such as the feedstock's physical and chemical properties, which we know can change all the time, the degumming method used, as well as the adsorbent that's introduced to remove these impurities.
So you mentioned that feedstock pretreatment is really the key to a refinery's production of renewable fuels, yet it can be quite complex. So, what solutions does Grace offer today to help resolve this complexity?
Yeah, so going back to the 80s first, Grace was actually the first to position and patent the use of synthetic amorphous silica in edible oil refining. But since then, our Tricol silicas have been globally adopted to help that industry get the most out of their bleaching earth adsorbents, which are really great at removing color bodies from edible oil. However, in this industry, color is not a feedstock specification, so therefore bleaching earth is not always necessary for renewable diesel and SAF pretreatment. But because the pretreatment process was adopted from the edible oil industry, many pretreaters or HVO refiners have started up and still use bleaching earth today. However, our customers who have switched to Trisol have noticed substantial improvements in their productivity, safety, and sustainability. So, first of all, Trisol is a synthetic hydrogel, meaning the adsorbent contains roughly 60% moisture, but it does not contain any detectable amounts of metals. All of this put together really allows the polar contaminants in the feedstock to have a higher affinity to Trisol, requiring a much smaller adsorbent dosage when compared to bleaching earth. Additionally, there is typically a vacuum pulled after the adsorption step where the moisture is removed from the adsorbent and feedstock mixture, and then the solid fraction of the adsorbent and the contaminants are filtered out. So, because Trisol's mass will shrink to 40% of its original amount during the drying process, less solid particles are introduced to the filter and less feedstock is lost in the filter cake. This really expands filter cycles and allows more feedstock to stay in the refining process. In the end, the total yields of renewable diesel and SAF can increase at these refineries without them really needing to secure any additional feedstock. In regards to safety, Trisol is composed of 100% amorphous silica and does not contain crystalline silica, which OSHA has associated with multiple hazards and health conditions such as silicosis, lung cancer, and kidney disease. And as the industry looks to reduce waste and emissions, the amount of adsorbent waste generated from these pretreatment units that utilize bleaching earth is a tremendous concern. With Trisol, introducing less solids into the pretreatment process not only extends filter cycles and productivity, like I mentioned before, but it really also helps reduce the amount of filter cake waste that is generated up to 85%. And the fuel requirements needed to send that waste to the landfill are also minimized.
Awesome. So, given how one refinery is different than the next, how does Grace work with customers to help them find the best cost effective yet sustainable solution for pretreatment?
Yeah, so at Grace, we know that this is really not a one size fits all solution. And that's why collaboration is really key to how we work with our customers. So typically, the first thing we do is interview the customer and kind of learn about how their specific refinery is set up. What are the typical feedstock impurity levels that they see, and what's their overall production capacity? Then we typically provide a preliminary cost savings and a waste reduction estimate with our in house economic model. The second thing we do is really look at their feedstock. So we get samples of their feedstock. We then analyze them for the initial contaminant levels with our internal ICP method. Then we run a series of trials with Trisil at different dosage levels. And this really allows us to figure out what the optimal Trisil dosage amount would be at their commercial scale. So after we run all those trials, we then look at the finished feedstock with ICP again to determine how much of those contaminants were removed. In most cases, our customers want to run a commercial trial before switching to Trisil. So, given the lab data that was previously generated, our technical customer service team will then kind of put together a trial proposal and we'll travel to the customer site to support the trial in person. And then, based on those results, our technical team then determines what the optimal Tricol dosage actually is, and then we refine the previous economic model estimation. Once the customer adopts Tricol technology, our support really does not stop there. Our technical team continues supporting the pretreatment unit as needed and offers reoccurring training to refinery personnel on an as needed basis. And then in situations where troubleshooting is needed outside of the pretreatment unit, Grace can also bring in technical support and resources from our other business units, as Grace is really the only adsorbent and catalyst supplier that understands the entire renewable diesel and SAF production process from feedstock to fuel.
Wow, that's really helpful. Very thorough support provided there. So, looking at other feedstock sources outside of triglyceride-based fats, oils, and greases, what is Grace doing to ensure other renewable technologies come up to scale?
So we value continuous innovation, and across Grace, all of our business units are working to ensure other renewable technologies come up to scale by continuing to research and develop new and improved solutions in close relationships with our customers. But outside of Tricol Silica adsorbents, our JV with Chevron, also known as ART, they recently launched their Endeavor Catalyst line as a drop in solution for hydrotreating a wide range of feedstocks to renewable fuels. Additionally, Grace's FCC business has been supporting the co processing industry by utilizing bio derived feedstocks since the early 2000s. And to help support the adoption of electric vehicles, our specialty catalyst business unit has developed polyolefin catalysts for lighter weight but stronger plastics. These are just a few examples of some recent innovations here at Grace. But all in all, sustainability is a key area of focus for the industries that we support. And we are fully committed to helping our current and potential customers meet their sustainability targets.
Awesome. Thank you, Chelsea. And thank you to Grace for sponsoring this podcast.
Yeah, no problem. Thanks for having me.
Absolutely. And Grace's white paper can be found linked in the description of this podcast. We hope all of our listeners can catch us again next time. Thank you so much.